Hello guys, welcome back to my YouTube channel, and for today's video we're going to tackle about the chapter 7 in the NetAcad, which entitled IP addressing. So without further ado, let's get started. So the first thing that we're going to tackle is about the IP addressing. So before I start, so basically these chapters is all about in detail the structure of the IP addresses and their application to the construction and testing of IP networks and subnetworks. So let's go back to the IP addressing. So IP addresses are hierarchical with a network and subnetwork. So an IP address can represent a complete network, specific host, or the broadcast address of the network. So an IP address are managed by the Internet Assigned Numbers Authority, or the IANA, so which has the overall responsibility for the Internet Protocol, or the IP address pool. So as and by the regional Internet registries, or to which IANA distributes large blocks of addresses. So basically, just are those are some infos in the IP addressing, and then we will proceed next to the binary. So binary is the numbering system that consists of numbers 0 and 1. So that the 0 and 1 called bits. So in contrast, decimal numbering system consists of 10 digits, consisting of the numbers 0 to 9. So binary is a based two numeral system, which represent each numerical value using a sequence of zeros and ones. So the binary systems implement positional notations and increasing in power of 2, and so on and so forth. And all numbers between 0 and 255 can be represented as an 8-bit string. And of course, the binary is important for us to understand because host servers and network devices uses binary addressing. So specifically, they use binary IPv4 addresses to identify each other. So next thing that we're going to tackle is the IPv6 and the IPv4. So in most of data networks, the largest population of hosts includes the PCs, smartphones, tablets, iPhones, and printers, and many other devices. So it is also often that case that the user population and their devices change frequently. So it would be a practical to statically assign an IPv4 addresses for each device. So therefore, these devices are assigned uh, in IPv4 address dynamically using the dynamic host configuration protocol, or the DHCP. So a host can be obtained, of course, in IPv4 addressing information automatically. So the host uh, is a DHCP client and requests the IPv4 address information from the DHCP server. So, what does the DHCP server do is that this server provides an IPv4 address, and also it provides the subnet mask, also provides the default gateway and other configuration informations. So And also the IPv4 host can communicate one of the three different ways. So first is the unicast, next is the broadcast, and or what you call the multicast, and also blocks of addresses that are used in network that required limited or no internet access are called private addresses. So, however, not all of the available IPv4 addresses can be used on the internet. So, other are the private addresses that you cannot access by and can be only accessed by the owner or the authorized person only assigned to that website or web page. So, there are block address called private address, just like I said a while ago. So that are used by most of the organization to assign the IPv4 addresses to their internal host. So next is the IPv6. So the IPv6 addresses are 128 bits in length and written as a string of hexadecimal values. So in every 4 bits is represented by a single hexadecimal digit. So for a total of uh, 32 hexadecimal values, uh, so an IPv6 addresses are not case sensitive, which means that it can be written in either uppercase or lowercase, and also like the IPv4, there are also three types of IPv6 addresses, which is the unicast, multicast, and anycast. So an IPv6 link local addresses enables device to communicate with other IPv6 enabled devices on the same link, and only on that link, which is also called as the subnet, and then packet with a source of or destination link local address cannot be routed beyond the link from which the packet originated. So unlike the IPv4, the IPv6 does not have a, a broadcast address. However, there is an, an IPv6 all node multicast address, so that can essentially gives the same result. So that is all about the IPv6 and the IPv4. So next is I'm going to discuss or tell other information in the chapter 5. So the ICMP, or the Internet Control Message Protocol, is available for both IPv4 and the IPv6. So first is I'm going to talk about the ICMP, or the Internet Protocol Message or Internet Control Message Protocol. I will discuss that first before I will discuss its application for IPv6 and IPv4. So the ICMP, or the Internet Control Message Protocol, is an error reporting protocol network devices like routers used to generate error messages to the source IP address when network problems prevent delivery of the IP address or IP packets. And any IP network devices has the capability to send, receive, or process the ICMP messages. So the ICMP is available for both the IPv4 and the IPv6. So the ICMP v4 is the messaging protocol for the IPv4, and the ICMP v6 is what does is it provides the same device services for the IPv6, but includes additional functionality. So after it is implemented, an IP network needs to be tested to, of course, to verify the connectivity and the operational performance. So that's it for today's video. So we're going to have a recap. So first is we talk about the IP addressing. So IP address are managed by the IANA. So which IP addresses are the hierarchical with network and subnetwork and host portion. So also an IP address can represent a complete network and a specific host. And the binary, so binary is a number system that consists in 0 and 1, and it is important for us to understand because hosts and servers and other devices uses, of course, the binary addressing. So next is the IPv6 and the IPv4. So both are them have the different types of uh, different ways of or how they communicate. So in the IPv4 is the unicast, broadcast, and multicast, while in the IPv6 is the unicast, multicast, and anycast. And the in IPv6 addresses are 128 bits in length, while in the IPv4 it is a 32 bits in length. So next is the that's so I think that's all of it. So if you like this video and if you learn something, please leave a like and share and support my channel. Thank you for watching. Bye bye.